We started off the day with talking about building for the Internet of the future. In the Internet future, we have to think about some new problems. And one of those problems is, how do we think about security in a post-quantum computer world? This is one of these new technologies that Chuck talked about, right? We got to think about everything we've built over the last 30 years and everything we've done with security has now got to work in a world where we have quantum computers. So if you were going to think of what is some research Cisco is doing, you would think this is one of the areas we're going to spend some time on, is how do we think through this problem and basically be able to provide the level of privacy and security we've all come to expect. So David McGrew is going to join me on stage to talk a little bit about that. Come on up, Dave. Hi, David. Welcome.
Hi, David.
All right. So you've been at Cisco a while, right?
20 years.
20 years. And what have you been spending your time doing?
It's been good.
You've been working on all kinds of encryption technology for the last 20 years, right? How do we think about privacy and security on the Internet?
Exactly. You know, I started out, the first task was to make encryption go as fast as the network speed, and we've done that, and encryption is foundational to the security of everything we do. Okay, so David's a pretty humble guy, but if you're thinking about like any technology used on the Internet, about how you do security and all the encryption algorithms, you've had a hand in building all that stuff over the last 20 years, whether it's elliptic curve cryptography or RSA or driving TLS 1.3. This is the guy that's been driving that both in the standards and all the implementation across the portfolio. So now you've been thinking about this question, quantum computers, and they're on the horizon. It's not a question of if, it's a question of when. There's a lot of research going into this. It's going to be a great thing when they're here. But what's the dilemma with security and privacy on the Internet? So a quantum computer would be able to break all of the public key cryptography that's in use on the Internet today. So a quantum computer would bring all sorts of wonderful benefits. That's why people are trying to build one, right? It would revolutionize medicine and material science. And so billions of dollars are being spent by companies and governments around the world because of these great benefits, but then public key cryptography is going to be roadkill.
So all that, this life's works, Dave, like a quantum computer is going to come along and people could record a session and then break the encryption. So we need to think about, okay, what are we going to do? So that's the question you've been thinking about. So let's look at what have you actually been working on and how do you think about solving this problem? Because there's a lot of infrastructure out there we all rely on to be private.
That's exactly right. So in cryptography, we have to worry not just about the security today, but for tomorrow. So we want to be able to integrate in post-quantum secure technologies into the networks of today, right? So that's what we've been working on, is a way to integrate quantum-safe cryptography into every session key that an encrypting router would engage in.
Okay, so if I, just to kind of simplify this a little bit, you're thinking about, hey, there's all this encryption that's on the Internet, and that is basically subject to, it could be broken if we had a general purpose quantum computer, but what if we made the keys post-quantum secure, then could still use the same infrastructure, right?
That's exactly right.
So this is what it would kind of look like, just a little model here. You would basically have, let's build this out. You would basically have a post-quantum key source, and there's people working on, there's a whole industry around that, right?
There's all sorts of cool technologies there.
There's all sorts of stuff going there, and we've built prototypes of this too. I mean, we've got Pradeep over here. They're actually building prototypes of what this would look like. So this has moved beyond just the research phase. We're kind of experimenting with it. So the idea is we build an API off the equipment. We get the post-quantum secure key from that. And then we signal that to the other side. That's a pre-shared key. And then the infrastructure that we've set up, that is now post-quantum secure. Is that basically the way it works?
That's exactly how it works. So the great thing here is that the data plane that we have for IPsec and MACsec, that's post-quantum secure. We just need to get the key management post-quantum secure as well. So we built a nice, flexible way to bring in different technologies, cool things like quantum key distribution or code-based cryptography, to initialize symmetric pseudorandom functions. There's all sorts of different technologies people can apply, and each has its own trade-offs in terms of range or operational considerations. So we want to be able to bring the best new technologies into the networks of today. That's the goal of our research.
So I guess now we're going to start down the standards path so all of us can embrace this post-quantum world. So a lot of work left to do, but it's an important problem that we're thinking about at Cisco. All right, thank you.
Thank you so much.
All right.